In this video, I want to compare and contrast three operations, AND, OR, and implies. Let's start with AND. Here's the truth table for P and Q. Notice that it's almost always false. The only time it gets the true is at the top when everything is true, both P and Q. So let's take the point of view that AND is stingy about being true. Only one time out of four here. Here with three statements we see that even more emphatically. With P, Q, and R there are 8 combinations and there's only one of those that gets the true, namely when everything is true. P, Q, and R all have to be true. So again, this shows the nature of AND as being stingy about being true. Now let's look at the OR. Here's the truth table for P or Q. And notice that it's almost always true. It's only in the last instance where there's no truth at all, when both P and Q are false, that it gets the false. So OR is kind of like the opposite of AND. OR is very generous about being true. And here with three statements we see that even more emphatically. Now there's 8 combinations and there's only one of those instances that gets the false, namely when there's no truth at all, when P, Q, and R are all false. So here clearly we see that OR is very generous about being true. And now let's look at the implication. Here's the truth table for P implies Q. Notice that it is almost always true. The only time it's false is when the hypothesis P is true and the conclusion Q does not follow through as it should by also being true. So the implies is very generous about being true. That means the implies has the same sort of nature that OR does. So what's the deal there? Is that just a coincidence or is there something deeper at work? The answer is definitely there's something deeper at work. I'd like to show you what it is. In this video I want to compare and contrast three operations for both the implies and implies. For the particular OR and then is the truth table for P and Q. If you look at the truth values in red, you see that those are identical. The only time it gets the true, that means that those two statements are logically both P and the same thing. So let's take the point of view that AND is stingy the other statement about being Q true or not P. Only one time out of logically here exactly the same. So I asked, is it with three statements we see that even more emphatically at all. With P, Q, and R, and there are 8 combinations, and there's only one of those that gets the true. It's namely when everything is true. Or here, P, Q, and R now, you all can see that in the truth table here. So again, pause the video. You can the nature of AND down toward the bottom of the screen about being true. Rewind. Now let's look at the OR. But after you're convinced of this, here's the truth table this, of course, is a formal proof. And notice here's something I'd like for you to wrestle with. It's only in the last here that undeniably no these two, when P implies P and Q are false, Q or not that it P, gets the false. Those are equivalent. So OR is kind of like the opposite of AND. OR is very generous about being true. Do you feel it? And here with gut? 3 statements we see that even more emphatically to accomplish. If now you there's 8 combinations. So give this some and there's only one of those instances see if you can arrive at a point. Namely when there's no truth at all, equivalent not only P, because of the truth and R are all but also false. Because you understand so it here by clearly way of intuition that's OR is very generous would really like to wind up. And now let's look at the implication. Here's the truth table for P implies Q. Notice that it is almost always true. The only time it's false is when the hypothesis P is true and the conclusion Q does not follow through as it should by also being true. So the implies is very generous about being true. That means the implies has the same sort of nature that OR does. So what's the deal there? Is that just a coincidence or is there something deeper at work? The answer is definitely there's something deeper at work. I'd like to show you what it is. Here we've got the truth table for both the implies and for the OR. The particular OR we're interested in is Q or not P. If you look at the truth values in red, you see that those are identical. That means that those two statements are logically 100% the same thing. P implies Q and the other statement, Q or not P, are logically exactly the same. So I asked, is it a coincidence? The answer is no, it's not a coincidence at all. And implies actually is a certain kind of or. It's this particular or here. Now you can see that in the truth table here. If you need to pause the video, you can put the cursor down toward the bottom of the screen and you can pause and rewind. But after you're convinced of this, and this of course is a formal proof, here's something I'd like for you to wrestle with. You can see here that undeniably these two, P implies Q, Q or not P, those are equivalent. But do you understand it? Does it make sense to you intuitively? Do you feel it in your gut? Now that would really be a great thing to accomplish if you could get there. So give this some serious thought and see if you can arrive at a point where these two are equivalent not only because of a truth table, but also because you understand it by way of intuition. That's the place where we would really like to wind up.